Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video, we are going to solve another question that was asked in TIFR 2024 chemistry paper. Okay, it is based on Beer-Lambert's law. It is a very good question. Okay, so this is a question that is given. A 1 millimeter thick transparent crystal of metalloprotein absorbs 75% of light of wavelength 500 nanometer. What is the extinction coefficient? Density is given and the molecular weight is given. Okay, so this in this question the formula is very simple that we are going to use. The more important thing is how carefully you do the unit conversion, because that is very important. If you do mistake in that, then you will not get the final answer. Okay, so let us write down one by one all the data that is given. 1 millimeter thick transparent crystal. Okay, so before writing the data, let us first understand what is the formula for Beer-Lambert's law. Okay, Beer-Lambert's law. What is the formula that we are going to use? Absorbance A is equal to epsilon Cl. What is epsilon? Epsilon is molar extinction coefficient. Okay, that is what we have to find out. C is the concentration of the solution, unknown solution. L is the path length. Okay, A is what? A is the absorbance. Okay, now what is given to us? Path length is given. Absorbance is not given directly, but we have to calculate, and concentration also we have to calculate. So let us first write down the path length L. Okay, L, it is given 1 millimeter. Okay, but if you see here in the final answer, we want it in centimeter. So we will convert this 1 millimeter into centimeter. Okay, 1 milli is 10 raised to minus 3. Okay, so this will be 10 raised to minus 3 meter, and 1 meter is how many centimeter? 100. Okay, so 1 into 10 raised to minus 3 into 100, I can write it as 10 raised to 2 centimeter. If minus 3 plus 2, that will be 10 raised to minus 1, or I can say 0.1 centimeter. Okay, so we got the path length. Now we can find out the absorbance. Okay, second one, absorbance. What is the formula? Log of I0 by I. Okay, what is I0? I0 is the incident light. Okay, incident light is how much? 100%. And I is what? I is the transmitted light. Okay, transmitted light. Okay, so how much is absorbed? The absorbed light they have given, that is how much? 75% is absorbed. So how much will be transmitted? 100 minus 75. Okay, 100 minus 75, that will be 25. Okay, 25. So 100 divided by 25, that will be log 4. Okay, log 4 value comes out to be how much? It is 0.602. 0.602. Okay, so now we have got the absorbance value as well. Okay, now what we have to calculate is the concentration. Okay, concentration or molarity. What is the formula? Number of moles N, okay, divided by volume of the solution in liters. Okay, so what is the formula for moles? How do you calculate moles? M, that is the mass of the solute, divided by mass divided by molecular weight M, capital M. Okay, this is the molecular weight, okay, into volume. Okay, now what is given to us is density is given, right? Density is given to us. Okay, so that we can write here, density is 1.5 gram per ml. Okay, but here we want the volume in liter. So 1 ml is how many liter? 1.5 milli. Milli is again 10 raised to minus 3. 1 milliliter is 10 raised to, milli is 10 raised to minus 3. Okay, so density in gram per liter will be 10 raised to minus 3 will go to the top. It will become 1500. Okay, 1.5 into 1000 gram per liter. Okay, gram per liter. So now this mass into mass divided by volume, that is nothing but density, right? Density is mass by volume. So that I can substitute with density. Okay, so density we have written down the conversion, that is in gram per liter, that is 1500 gram per liter. Okay, and molecular weight, again we have to do the unit conversion. Okay, why we have to do the unit conversion? Because here you can see the molecular weight is given in kilodalton. Okay, kilodalton, but we want in what? We want in terms of gram, because here it is gram that is given to us. Okay, so we have to convert the molecular weight from kilodalton to gram. Okay, so that conversion we must know. Okay, 1 dalton is equal to 1.66 into 10 raised to minus 24 grams. Okay, it is minus 27 kilogram. 1 kilogram is 10 raised to 3 grams. Okay, 1 kilogram is 10 raised to 3 grams. So 27 minus 27 plus 3 will be 1.66 into 10 raised to minus 24 grams. That is 1 dalton. Okay, but we have how many daltons? The value given is 100 kilodalton. Okay, so that will be 10 raised to 2 into kilo, that is 10 raised to 3 into 1 dalton we have written just now, that is 1.66 into 10 raised to minus 24 gram. Okay, so this value of molecular weight, okay, molecular weight, that comes out to be this. If you calculate, this comes out to be 1.66 into 10 raised to minus 19 grams. Okay, 1.66 into 10 raised to minus 19 gram. Okay, this was a key portion where you must know the conversion from dalton to gram or kilogram. If you don't know this, then you cannot solve this. Okay, and it was not given. Okay, so molecular weight is how much? 1.66 into 10 raised to minus 19 gram. Okay, now there is one more problem. What is the unit for molarity? It is mole per liter. Okay, now gram will get cancelled. Okay, but we don't have the term for mole. Okay, we want mole in the numerator. So what you have to do? You have to multiply here by the Avogadro number. Multiply the denominator by the Avogadro number, that is 6.022 into 10 raised to 23 mole inverse. Okay, so this mole inverse will go to the numerator and the final unit will be mole raised to 1. Okay, that is mole per liter, or we can say molar. Okay, you solve this. Okay, the final answer for concentration comes out to be 0.015 molar. Okay, so now we have also got the concentration. Okay, so now we can substitute and calculate the value of molar extinction coefficient. Okay, so now we can calculate the value for molar extinction coefficient, that is epsilon. Okay, that will be A divided by C into L. What is the absorbance? Absorbance we have calculated, it is 0.602 divided by concentration, that is 0.015 molar into path length, that is 0.1 centimeter. Okay, molar raised to 1, centimeter raised to 1. So the final answer will be molar raised to minus 1, centimeter raised to minus 1. Okay, and that comes out to be 401. Okay, the final answer is 401. So now you have to convert it into the given format. Okay, 401, I can also write it as 4.01 into 10 raised to 2, that is 4 into 100 is same as 400. Okay, molar raised to minus 1, centimeter raised to minus 1. Okay, so the closest answer, power is 2. Okay, 10 raised to 2, how you can write this? 4.01. Okay, 10 raised to, this is written as E. Okay, capital E. Then power is written as like this, E plus 2. Unit is molar inverse, centimeter inverse. Okay, so what is the correct answer? Okay, the correct answer is what? Option C. Okay, 4 into 10 raised to 2 molar inverse centimeter inverse. So what is the correct answer? Option C. So this is a very good question in terms of unit conversion. Okay, so I hope you have understood all the conversion. First, we converted millimeter to centimeter. Why? Because the final answer needed in centimeter inverse. Second, we calculated absorbance. Okay, and then we calculated the concentration. Okay, concentration. Here there was this trick that mass by volume. This you have to substitute with density. Then again there were conversions in density that we converted gram per ml into gram per liter. Okay, because the unit of volume here it should be liter inverse. Okay, and then there was missing term of moles. Okay, so that is why we multiplied by Avogadro number. Okay, mole inverse. So you will get the final unit as mole per liter. Okay, and then substitute directly, you will get the answer. Okay, I hope you have understood the solution. Thank you.